Imagine you have a ship. Not just any ship. This one can travel at the speed of light, ignoring the pesky laws of relativity that say you're supposed to turn into pure energy if you try. You point your bow toward the dark, empty void of the deep cosmos, and you push the throttle to the floor. You fly for 1 billion years, then 10 billion, then 46 billion. You are moving through the fabric of space itself, looking for the edge. You're expecting a wall, maybe a shimmering curtain, or perhaps a sudden drop-off into nothingness. You are looking for the place where the universe simply stops. But as you reach that 46 billion light-year mark, you don't hit a barrier. You don't find a signpost that says end of reality. Instead, you look out your viewport and see exactly what you saw when you left home: stars, galaxies, filaments of dark matter, and the same cold, quiet expanse of space. You haven't reached the end of the universe, you've just reached the end of your own tether. Welcome to the most frustrating, beautiful, and mind-bending mystery in modern cosmology: the boundary of the observable universe. We often talk about the edge of the universe as if it's a cliff, but the truth is far more humbling. It's not a physical boundary, it's a perspective limit. And what lies beyond that limit is a question that challenges the very nature of existence. To understand why we're trapped in a bubble of our own making, we have to talk about the cosmic light horizon. Think of the universe like a massive, darkened auditorium. We are sitting in the middle, and we have a flashlight. The light from our flashlight, the oldest light we can see, is the cosmic microwave background. It's the afterglow of the Big Bang, dating back to about 380,000 years after the beginning of time. Because the universe is roughly 8 billion years old, you might assume we can only see 8 billion light years in any direction. But space is expanding. It's stretching like a rubber sheet being pulled from every corner. The light that left those distant objects billions of years ago has been traveling through space that was expanding the entire time. By the time that light finally reached our eyes, the objects that emitted it had been carried much, much further away. That is why the observable universe is a sphere with a radius of about 46 billion light-years. It's not a measurement of how far light has traveled. It's a measurement of where those light sources are now. But here's the kicker. Everything beyond that 46 billion light-year horizon is currently receding from us at a speed faster than light. Now don't panic. Einstein's rule that nothing can travel faster than light through space still holds. But space itself can expand at any speed it likes. Because the space between us and those distant regions is expanding so rapidly, the light from those galaxies will never, ever reach us. We are effectively living on a lonely island, surrounded by a fog that we can never peer through. So what's out there? Is it just more of the same? Cosmologists rely on something called the Cosmological Principle. It's a fancy way of saying that the universe is homogeneous and isotropic. In plain English, the universe doesn't have a center, it doesn't have a preferred direction, and it doesn't look different anywhere else. If you were to teleport 1 billion light-years past our current horizon, you wouldn't find a different set of laws. You'd find more galaxies, more superclusters, and more cosmic webs. The universe, as far as we can tell, is a fractal of repetition. It's a vast, sprawling landscape that looks like a mirror image of our own backyard, stretching out into the darkness. But this leads us to the most uncomfortable possibility of all, the infinite universe. If the universe is spatially infinite, meaning it literally never ends, then the implications are staggering. If you have an infinite amount of space and a finite amount of ways to arrange matter, then eventually, patterns have to repeat. Mathematically, if you travel far enough, an unfathomably long distance, you would eventually find another version of our solar system, then another version of Earth, then another version of you, reading this exact script, wondering the exact same thing. In an infinite universe, every possible configuration of atoms is not just possible, it is inevitable. You aren't just a unique individual, you are one of an infinite number of copies, playing out every variation of your life across the vast, dark tapestry of space. But what if it's not just one infinite space? What if our universe is just one bubble in a much larger, more chaotic sea? This brings us to the theory of eternal inflation. Imagine a pot of boiling water. The water is the multiverse, and each bubble that forms is a pocket universe. In this scenario, our universe is just one bubble that stopped inflating, allowing stars and galaxies to form. But outside our bubble, the water is still boiling. Other bubbles are popping into existence, each with their own laws of physics, their own constants, and perhaps even their own dimensions. In some of these bubbles, gravity might be so strong that stars never form. In others, the electromagnetic force might be so weak that atoms can't hold together. We live in a Goldilocks bubble, one where the physics just happen to be right for life to emerge. This is where the mystery moves from science into the realm of the profound. We are separated from these other regions by an information barrier that is absolute. Because the space between us and these hypothetical regions is expanding faster than light, there is no signal, no probe, and no message that can ever cross the gap. They are, for all intents and purposes, in a different reality. This realization forces us to confront our own insignificance. For most of human history, we thought we were at the center of everything. Then we learned we were just a rock orbiting a medium-sized star in the suburbs of a galaxy. Then we learned our galaxy is one of trillions. And now, we are learning that even our entire universe might be just a tiny, fleeting bubble in a vast, frothing ocean of other realities. It's easy to feel small when you look at these numbers. It's easy to feel like our existence is a statistical error in a cold, indifferent vacuum. But there is another way to look at it. We are the part of the universe that is capable of wondering about the edge. We are the consciousness that the universe grew to look back at itself. Whether we are a lonely island in a sea of nothingness, or one of an infinite number of bubbles in a multiverse, the fact that we can stand here, look up, and ask these questions is, in itself, a miracle of physics. We may never see what lies beyond the horizon. We may never know if there are other versions of us out there, or if the laws of physics change as you drift into the deep dark. But the mystery is what drives us. It's the fuel for our curiosity. The edge of the observable universe isn't a wall, it's a challenge. It reminds us that no matter how much we learn, there will always be a horizon just out of reach, waiting for the next generation of dreamers to try and catch a glimpse of what's hiding in the dark. If you could build a ship capable of traveling to the edge of the universe, knowing you could never come back, would you do it? Would you sacrifice everything just to see what's on the other side of the horizon? Let us know your thoughts in the comments below. And if you want to keep exploring the edges of our reality, make sure to subscribe and hit the notification bell. We're only just beginning to map the dark. Stay curious, and we'll see you in the next one.